Hello, welcome back to BSLIVE. In this episode, I want to share the breakdown on how I created this type of artworks. They are kind of like abstract lookings. As you can see, it looks like nothing you have ever seen before because it's super abstract and it looks like it's made of multiple materials, organics, maybe slightly plasticity. Like you can see plastics, maybe glass, metals, all kind of mixed up together. This one, of course, more like organic, liquid, and this one maybe foamy, slightly foamy, but it's pretty crazy looking, right? And this one is more like a fabric material. I was using Stable Diffusion AI to generate all of these imageries. I specified all kind of different prompts, but the base shapes actually comes from Blender. I'll show you. Okay, this one is kind of interesting. I actually specify like kind of like a monster, creatures, and whatsoever, and you're gonna get endless, infinite amounts of results, right? This might not be the final artworks. I might create something based on this concept, but yeah, the origin was actually created using Blender. So yeah, I want to talk about this as well. This is inside Plasticity. I'm still kind of tweaking around. This could be a design of some sort. I can 3D print it. Okay, I'm using this app called Draw Things. I think this is the best app to quickly generate anything. If you are using Mac OS, iPad, or iPhone, you can actually use this app. So this is the thing that's coming from Blender, right? Which is actually just random extrusion based on these old setups. If you have watched my videos from many years ago, this is actually one of them. So what is this exactly? First of all, let's turn off the SVerchok extrusion. So this is what it is. It's geometry nodes on a curve object. So it's geometry nodes procedurally generating these random shapes. This looks slightly complicated. Not really. It's basically like I am resampling a circle geometry, and then I instance just a bunch of random circles using this setup, just random points, create bunch of points using random value, and then just scatter it and then instant the points, and then realize the instances. And then after I do that, I set the spline type to poly. I can actually set this to NURBS as well, so if you want to have like rounded result. Let's keep it polygon for now. The rest of them that looks super complicated here is just basically a way I can further randomize and then like disturb the points. If I didn't do that, if I zero out the randomness, it's basically just like end gone. So I randomize the points, so I get something like random shapes like this. So from here, what I want to do is like just like inside Plasticity, if there's an area I want to quickly extrude up, and geometry nodes cannot really do that. Maybe you can, but I know the quick way using SVerchok. Okay, from geometry nodes output like this, I can use SVerchok just to get the area and then just extrude it up. So this is the nodes. Get the intersecting edges. Use planar edge net to polygons. So we get the area of faces, and then insert special. So I can create mountain this way. this is the amount of extrusion, and we can randomize the seed. Yeah, the bottom part is actually hollow, so I don't know, maybe that's not a good thing. You can fill up the bottom part using SVerchok as well. Just for simplicity, I just duplicated this guy. We have just a simple geometry now. It's no longer procedural. I go to edit mode and just select all, F, fill the hole. After I do that, I just remesh, you know, and then I get this shape, and then I can send this into AI. So I can use AI for that, or if we really want to, what I did actually to convert this to mesh, and then I use sculpt mode. You have seen me doing this many times. Just inflate it. Okay, so it's, I don't know, I kind of like the shape. If we really want to, you know, you can always do like sculpting. This is, I think, the most fun part. Yeah, you're adding your own shape on top of this abstract looking geometry that's originally is procedural, right? We are using SVerchok geometry nodes, but on top of that we really want to reshape this. So I found this part is fun. I can do this all day, you know, like Yayoi Kusama, you know, like the artist Yayoi Kusama. You can just keep doing this all day because this is the fun part. It's not finished. I can paint this into something else, but I decided to send it to AI, and I just then play around with the ideas. So this probably could help me to generate the final artwork, which is gonna be maybe like 3D. I don't know, I can paint it out. I can do all sort of things. This gonna generate things infinitely. I can keep adding prompt or reducing the prompt. So this is the prompt. Yeah, basically masterpiece of densely packed surreal artwork featuring colorful chibi monster shapes, creatures, and objects. Chibi is like a Japanese word for like a small creature, monsters, like a small character. Chibi can be like a toy or something. I can actually specify robot. I'm gonna get something that's looking more like a robot. However, I don't stop there. This is something that I'm working inside Plasticity. This is another app that I really love besides Blender. So you can have organic shapes like this. Once you sculpt it, it's no longer procedural. Inside Plasticity, however, if you manage to bring it into Plasticity, like what I'm doing here, you can do more like kind of pushing and pulling the organic shapes. It's okay because I added bevel. It's no longer organic. I can still push and pull some areas, which is something I really like from Plasticity. I want to show you how. Okay, so let's delete everything. We like the abstract shapes, and we want to be able to, I mean, you can do it inside Blender, extrude it, maybe use grid modeler, or maybe use box cutter, you know, just doing all sort of crazy things that you can do on the 3D objects. As for now, really, we can just export this into Plasticity. Okay, these shapes, hopefully. So yeah, this is a curve object, but we cannot just apply the curve. This is Blender geometry nodes limitations. I don't know why cannot convert curve to mesh. So I just need to duplicate this, right click, convert to mesh, so it's becoming a mesh object. Right click, convert it back to curve. Now it's a curve object again, and I want to convert this curve into Bezier. Now this is a Bezier curve. We can file, export. I'm using this add-on called Bezier to SVG. Okay, we need this step. Unfortunately, we cannot just export it to Plasticity, which is slightly annoying, but this is a good way around it. So this is LeoMoon Bezier to SVG. It's a free add-on from LeoMoon Studios. Highly recommend it. Yeah, LeoMoon Bezier to SVG, and this is the video talking about it. Anyhow, so I export it out, right? And then now we have we need also FreeCAD. We need to convert the SVG into step file format so Plasticity can read it. It's a slightly painful process, but it's pretty simple. So I think, you know, it's just you need to bring from Blender. Because you want to send it to Plasticity, and yeah, you just need this step. So Blender export to SVG, SVG export to step using FreeCAD. Okay, this is just these random shapes. I like the randomness, but also I want to make sure that it's still something that I can work on. So I just made another export to the desktop. We have this step format file. Now I can go import. I just click on this letter, import, step, open it, and suddenly we have something here. Inside Plasticity, it's really tiny. Maybe you want to scale this. It comes not as a curve, but as a sheet of object, and this is could be good, could be slightly annoying, but you know you can always select this and then Control 2 and then duplicate, select, Control 2, duplicate. This step is also slightly annoying. I mean, you select a sheet of the object and then you Control 2 and then duplicate the curve. That's fine, but this is in order to get the curve. You can't do it on many objects at the same time. I wish it can. So you can have this curve. Let me hide all this original sheet object. The curve seems like planar object, but they're not really. You need to scale this in the z-axis to 0, 0, 0. So after you do that, now it's becoming flat and planar. You can actually do this inside Plasticity. This is fine. This is okay. You can extrude this. The same thing that I did inside Blender using SVerchok procedurally. But Plasticity being Plasticity, I mean, if they're even you extrude it and they're kind of touching each other, you cannot just boolean it. Okay, so it's really weird, but I just want to show you. What I propose is, however, if you have this sheet of object, extruding it will do the magic. Okay, so because they're sheet of object, they're overlapping, and you know you can extrude them, right? The good thing is that they're actually overlapping each other, and then Plasticity kind of love that. So once you have this extrusion, the sheet object becomes solid. You can select all of them and then Q, and then now it's becoming a single object. And this object is actually pretty cool inside Plasticity because you can still push and pull. I really like this feature. It's really weird way of working with CAD, and I think only Plasticity does this. Maybe there are other 3D package that actually does this, but this is the one I have anyway. Plasticity is the cost is pretty low, and then once you do, pushing and pulling, you can actually do it down there as well. So it's like the one we did before, like extruding the shapes. Just because plasticity is using this PARASOLID method, and then you boolean this into a single object, like single PARASOLID objects. Yeah, you can push and pull faces in a weird way. It's not like a Blender extrusion either, because sometimes you get quite a surprise result. So let me save this. I kind of talk a lot. This is still kind of experimental, but I like it. You know, plasticity. You can just, if you like a corner, you can bevel it like this way, or you can do that kind of bevel or fillet. You can just quickly make cut like that, which is something I like. If you are designing building, you know, like architecture building, you can, the fact that we can do this quite easily is it's a lot of fun. And if you like, you can always use, you know, like box cutter. You can make a cut that way. This is also kind of neat. It's really powerful workflow. So it's just up to you now. It's just doing this type of thing. Use O to inset. You can make a building like Guggenheim building, type of building that's a little bit abstract looking. The shape is quite organic, and we can just, you know, do this type of bevel. So I think this is more like form before function. If you're doing AI generative artwork, yeah, you probably find a lot of really weird shapes, or in case of AI, it's not just shapes. It's like a concept. You don't know exactly what it is, but this is creating the form, creating the render before you are actually doing the actual design. I don't know why people would do this. It's still like, I find it like experimental. Even for me, I am kind of questioning this method a little bit. So if you're an artist doing abstract things using 3D, you might like doing it like randomly. I mean, in the near future, or if you are using VR and you have like method like using SDF volume, and then so you can, you know, quickly, you can achieve any shapes pretty much using basic primitive shapes, you know, just boolean volumetric objects together, boolean difference union, those sort of things. You can do all of those, which is fine. The tools that I have at the moment, using Blender and Plasticity, I can achieve this type of hard solid modeling. So it's not totally like sculpture like. If I'm actually using Plasticity, it's more like CAD, right? Like it's actually closer to like a architecture type of design. Normally, I don't know, if you're an artist, you find aesthetic shapes like this using found objects on the street. Find, you know, objects that people throw away, and then you create something. So if you're doing it in 3D, like what I'm doing here, using random 2D shapes that's being extruded into PARASOLID inside Plasticity, you can kind of doing the same thing. you're making like a cut and make some areas rounded, pushing and pulling in some areas. Maybe this is a type of thing that's actually an artist love to do, or a designer if you're actually a little bit of like a designer. I don't know. I'm just showing you the method. Maybe you will like this. Maybe you will find this too complicated, but I found it okay because this plasticity it's unlike any other CAD model out there. Unlike any other CAD apps out there, this is actually a lot of fun, just pushing and pulling the shapes. And then from here, maybe you decide, okay, turn this into a real building in real life. Who knows? Maybe that's a good thing. Super abstract, but no, because it's like a 3D. This is something that you can print out, right? So that's my main point. And this is the shape of this, because it's like a more like hard surface 3D modeling. Some people like this type of things. Some people will prefer like more organic, like this type of thing. And yeah, from these shapes you turn it into something that you actually believe, that something you can turn it into like a mechanical object. This is what's the AI showing, right? Based on the shapes. Yeah, so it's with the AI it's gonna be like infinite creations, but what you want to create in the end, maybe for your own your own artistic style, to make it more like your style, you can maybe print this out and then do something a little bit more, do a little bit more inspired by this AI render. Or you can just you can just simply paint this. You can paint. The most basic and simple thing is just paint. Yeah, so sculpting, painting, it's all just like more like traditional. If you started to get into something, okay, something that you can print out, maybe this could be like a useful design, something you can sit on. Then the form kind of changing, it's become a new functions. It's no longer what it looks like before. So this is form before functions, definitely. Yeah, you're totally. I think the fact that I really like the fact that the shapes is actually kind of organic, but because this is the shapes that plasticity kind of like this type of PARASOLID. So from the sheet of objects that you export from Blender, again from these 2D shapes, random 2D shapes brought into plasticity, and then boolean together into this form of parasolids that can infinitely being extruded, and you can just keep doing this non-stop. You try to find the angle that you can extrude or bevel, and you just keep going. Maybe this is also something, okay, you like these shapes, okay, you decided file, save as obj, random abstract stuff. You can export it as quad or n-gone. Back into Blender, file, new, file, import, obj, rx minus 90. You get this shape now inside Blender, and you can do more to this. Maybe paint some textures. I don't know, you can export this as AR objects. You can do mirroring if you want to. All sort of thing that you find interesting. You can always remesh this. Remesh, right click, convert to mesh, and once again, you know, back to the sculpt. You can sculpt. You can also use the cloth filter once again. Finally, before I finish, just inflate. I like the inflate. It's like it looks like a balloon, right? Once you got these shapes, you can send this maybe to AI and create more organic looking result. This one is probably more like a robot because we specify the robot. I should just say maybe organic monster shapes, creatures, and I'll make it smaller. So it's gonna be faster. Okay. Oh, yeah. From Blender, if you want to get, you want to have the depth. This is, I'm using ControlNet, by the way. This is ControlNet depth map. So from Blender, you actually want to get the depth shape because you can't have the full 3D for AI because it works in latent space. So you want this to be like just a simple depth that the AI would understand and then turn it into something else. So yeah, that's the whole process. It's pretty crazy. I know it's going from one basic shapes into another, procedural, geometry nodes, SVerchok, export into Plasticity, and you know, a lot of techniques and stuff. But I think this is something I quite like, and I like to share with you. Maybe it's gonna inspire for other things. So yeah, hopefully you'll find this useful. Thanks again for tuning in, and I'll see you next time. Thank you. Bye.